Hey everyone, welcome back to the channel. Hope you all are doing well. And today we will be discussing another problem from our binary trees. I'll just check if I'm live or not. Yes, we are live. So I'll show you the problem statement, then we can start off. Okay, so from your sheet, SD sheet, we will be solving this problem, which is symmetric tree. Okay, fine. So we discussed a problem of binary tree yesterday in which we were checking if trees were identical or not, right? So there is a small difference between the understanding of the two questions. By symmetric, what do we mean? I'll tell you. So you are given a binary tree, you have to check whether it is symmetric or not. If it's a symmetric, so by symmetric they mean that it should be a mirror image of itself. Now how is that possible? I'll give you an example. So let's see. Just a second. Okay, so let's say I have 10, okay, 20, 20. Then I have 30, 40, 40, 30, 50. Now you need to understand if this is a symmetric tree or not. How will you check if it's a symmetric tree or not? So for that you need to understand that for a tree to be symmetric, it should be a mirror image of itself. So let's see if it is a mirror image of itself. So in mirror, okay, you just think of superimposing each node on other. So 10 is symmetric to itself, 20 is definitely equidistant, symmetric to itself. Talking about 30, equidistant means just it's up to you how you want to understand what is mirror image of itself. So 40 is equidistant. So till here we have all the nodes that are overlapping with each other right at their nodes. And now let's check 50 is when I just think of folding it like that. Okay, if I fold it, will 50 be superimposed on this 50? No. So this tree is not symmetric. If I just do a small change, which is instead of keeping this node 50 here, what if I keep my node 50 to the left of 30? Now if you observe, now this tree is a mirror image of itself. If you fold it, for example, if you try to superimpose it, will I not get 50 right at this 50, right? So this is how you need to check. Now in terms of how we know what is a mirror image, we understood, okay, how you superimpose, but in terms of coding, what is the catch here that will help you determine whether this tree is a mirror image of itself? So you can observe one thing, that whatever is towards the, if I talk about this root, okay, 10 is the root, so whatever is towards the left of 10, that should exactly be the right of 10. So one by one we'll go 20 and 20. Okay, now if I consider 20 as my new root, so whatever is present at the left of 20, that should be exactly present at the right of 20. So if I talk about the left child of this 20, I have 30. So this 30 should become the right child of this 20 in order for it to be symmetric. Whatever is at the, if I talk about 20 as my root, so whatever is at the right of this 20 should be present at the left of this 20. So from here, what did you understand? That what for every node, the left child should ideally be the right child of the other root, whichever we are passing. So if you imagine these two as two different trees, okay, so what can I do? I can write a function, let's say helper function, which will take two different root nodes, right? Let's say this is R1, okay, and this is R2. So my check here is that if left of R1 is identical to right of R2, and simultaneously right of R2 is identical to left of right of R1 is identical to left of R2. You got my point? If these conditions hold true, which is if R1 dot left, right, is equal to R2's right, and also I want R1's right to be identical to R1 dot right should match with whatever is present towards the left of R2, R2 dot left. So if these things are holding true, considering that R1 dot val is already equal to R2 dot val. You getting my point? So what we are checking now, just divide your tree into two halves. Let's say one half of tree's root you are passing as R1, other is R2. Now repeat, but this was the case when, for example, you had only three nodes total. For example, this is one tree and this is one tree, right? I have just divided here for you to understand, but we actually want this process to repeat for every node in the tree. If I am doing this for this 20 and this 20, then same thing should be repeated for this 30 and this 40. So how will you do that? You know that this thing has to be recursively done. So when I am at 30, the other root that I'll be passing to this function would ideally be 30. And when they match, then I go ahead and check that whatever is at the left of this 30 should match with whatever is present at the right of this 30. Simultaneously, I'll check whatever from this line, whatever is present at the right of this 30 should match with whatever is present at the left of this 30. And if all of these recursively are returning me true, then I can say, okay, this 30 will return true for itself, this 30 will return true for itself. Then I'll check the same thing for this root, this node. Okay, so now I hope the recursion part is clear to you. The catch here was that you are passing, instead of, you're just kind of dividing your tree into two halves, one side of a tree, other side of a tree, there are two root nodes. Check the same thing for every node, that if the two root node values are same, then you check for the left of that node if that is identical to the right of the other node, and similarly the right of that node is identical to the left of the other node. Now you must be wondering what to pass when we have only one root node. Just pass that node twice. R1 will also be pointing to 10, R2 will also be pointing to 10. A tree node with only one node will always be symmetric node, right? So I hope you understood this. In case you have any doubts, you can ask me. And if you observe in all these recursions, we are going through each node at max once, right? So big O of n is the time complexity, right? When will be your time complexity, and recursive stack is going to take your space equivalent to the height of your binary tree, so that will be the space complexity, right? So let's move to the code, and code is again going to be simple. The catch about trees, if you are doing trees, the only catch about solving problems on trees is that to have a good grip over recursion. Now I have a function which I have to complete here is symmetric. I'll be taking a help, like you can say a helper function or whatever name you want to give. So in my symmetric function, I will return whatever I'll get true or false from that function, return helper. And helper function is going to have two root nodes, right, that I'll be checking for, that I showed you in on the whiteboard, blackboard, that I'll be passing node R1, node R2, right? Let's say we are passing this, but I'm making a call to the function which I'll define now. So the R1 initially will be root and R2 initially will be root only. Okay, so this is what I'm going to do. Now let's define this function, public static boolean helper is the name of the function I'm giving, root node R1, node R2. Okay, what is the first condition? First you have to check that R1 is equal to null and R2 is also equal to null. If both the root nodes are null, then what is there any point of checking return true? If R1 is equal to null and R2 is also equal to null, you are returning true. Then you are checking, I am checking, see the conditions you can put whatever comes to your mind first, that I am checking first, obviously this has to be a base condition. Then other thing is I am checking what if one of them is not null, or one of them is null and other one is not null. You can explicitly write this condition and return false, but I will handle the false in the end. Means where I do not need to write any condition. So this is my way of doing. You can do it in your own way, but you need to understand just that if R1 is also not equal to null and my R2 is also not equal to null, Now, one thing is for sure that I have some value in R1 and R2. Then I will check if R1 dot data is equal to R2 dot data, right? If this is the case, then I am going to make a call recursively and check that left of R1 matches right of R2 and right of R1 matches left of R2. These two things I am going to check recursively by making a call to my function and return. If all are true, I'll get a true helper R1 dot left, and that you will check for R2's right. And this thing return, I am actually returning. If this is the case, return helper and helper. What are you passing? R1 dot right, which ideally should match with R2 dot left. So this is what I'm doing. Okay. If all these conditions, basically if this function will return true and this function will also return true, I will get true for that particular, and if one of them fails at any point in time, I will return false. Okay, let's check and compile. Meanwhile, you guys, if you have any doubts, you can write in the chat. So that's all about this problem, guys. If you have any doubts, you can ask me. Okay. So I hope you understood the problem. You know now what is a symmetric tree. Symmetric tree are supposed to be mirror image of itself if you divide the tree into two by a line into two halves. Okay. So that is all for this question, guys. If you have no doubts, we will wrap it up. Fine then. Everyone, that was all for today. See you all in the next lecture. Thank you and take care.